Shall we start? Yeah? All right. Morning, everyone. Welcome to PaaSport to Paradise. My name is Sandy Vinarko. I'm the lead program manager for Microsoft Azure Data Governance team. My team is based in Shanghai, China. The extended team is actually covering both Redmond and China. We work on all the products that has to do with data integration and data governance. For example, Azure Data Catalog, Azure Data Share, Azure Data Factory, SQL Server Integration Services, Master Data Services, and Data Quality Services. Today, I would like to cover everything you need to know about running your ETL workload in the cloud using the recommended all platform as a service solution, which include Azure SQL Database and SSIS in Azure Data Factory. Before I start, maybe I'd like to know a quick show of hands. I'm guessing that everybody's here probably already used SSIS before, right? But anyone never used or doesn't know about SSIS before? Good, right? Everybody knows about SSIS. How about ADF? Everybody use ADF or never use it? Anybody never use ADF? So you guys never used ADF before. So obviously, some of you probably use ADF but never use SSIS in ADF, right? All right. So because this session is very short, it's 45 minutes, it's usually I do this type of topic like in the whole day pre-con session. So it's 45 minutes. I'll try to cover as much content as possible. So I would prefer if you have any question, you can do it at the end or find me later on. Tomorrow we have also a workshop or a hands-on lab session. It's called Back to the Future. Accelerating your legacy SSIS migration. I think if it's fully booked, you can come anyway, and then we can actually give you the demo script so you can try at home, and you can always find me there to ask me a question. I'm also at the Expert Connect session from 1 to 3 today and tomorrow. So if you want to come and ask me a question, you can do that too. And I also at the data migration booth at the hub from 4 to 6 today and tomorrow. So you have plenty of time to ask me a question later, okay? So before we start, I'll cover a little bit about the agenda. I will do a quick flash introduction about SSIS, about ADF, Azure Data Factory, and also about the integration of SSIS into ADF. And then I'll repeat basically the learning objective, why you want to lift and shift your ETL workload to the cloud, right? And after that, I will cover the best practice recommendation of using an all-PaaS solution to migrate your SQL Server estate. And then I will show you a bit of a background history. How do we actually evolve? How did we, Microsoft, evolve SSIS to run in the cloud? And all the design decisions we make to make sure your migration process is as seamless and as painless as possible. And then I will cover two alternative methods to access data on premises. I'll show you pros and cons, so you can select which one you prefer to use, right? And then finally, I'll cover the complete SSIS migration playbook, which is essentially a matrix of what you can do when you know where your packages are stored. There are 4 different package storage, and where's your migration destination, and what you need to do to migrate your packages in batch, and how you assess your packages, your SSIS job, etc. I'll cover that at the end, and then I'll try to do as many demos as possible. Okay? Okay, let's start with a quick flash introduction. SSIS is a really traditional ETL platform that's always bundled with SQL Server. It's been around for, I think, more than 10, 15 years, right? It came out in the market as a DTS, Data Transformation Services, and then I think in 2005, we rechristened it as a SSIS, right? It's really used for a customer who wants to move data in and out of SQL Server that you manage yourself on-prem locally, right? ADF is actually Azure Data Factory. It's a cloud-native data integration platform. It's born in the cloud for people who want to explore the modern data warehouse or big data analytics pattern, right? And as you can see, at Ignite, we launched a really big all-in-one analytics solution called Azure Synapse Analytics. ADF is a big part of that, okay? Now, a lot of SSIS customers want to run their workloads in the cloud. We know a lot of customers who have like hundreds and thousands of packages. For them to run SSIS workload in the cloud and like right away transforming those packages into ADF pipeline is almost virtually impossible. And that way, that's why we actually integrate SSIS as a native compute engine inside ADF. So it allows you to actually lift and shift with minimal or no change running your SSIS workload inside Azure Data Factory, and then modernize at your own pace, or even not modernize at all. You can always run SSIS inside ADF without change. As an analogy, you can see it, for example, SSIS is running on-prem. It's like the ground floor, right? ADF is like a 10-story floor. You cannot jump a 10-story in one hop, right? So SSIS in ADF is like an escalator or elevator that takes you step by step at your own pace to modernize your workload in the cloud, okay? The learning objective of this session is, like I mentioned before, once you know you want to use SSIS in ADF, the first thing you do is lift and shift. That's the easiest, the most seamless and painless way to run your workload in the cloud. Once you run SSIS in ADF, you can always modernize, because the feature of running SSIS in ADF is you can actually combine SSIS with different features that ADF offers. For example, once you run SSIS in ADF, you can actually trigger your SSIS workload based on a file arrival, or even based trigger. That doesn't exist on-prem before. So you have a lot of cloud-first, cloud-only features that allow you to modernize, right? And then, because SSIS in ADF is infinitely extensible, you can actually add all different connectivity, custom connectivity, or work with a third party or our partner to install open source, custom, or partner components on it. So the mantra that I keep repeating in this session is like lift and shift, modernize, and extend, okay? So let's go to the best practice recommendation about migrating your SQL Server estate. You start with the on-prem SQL Server. You have three, you can see the database engine is a SQL Server, and you have three main or principal value-added services, which is a SQL Server Integration Service, Analysis Service, SSAS, or Reporting Services, right? There's also like secondary value-added services, like I mentioned before, which is Master Data Services and Data Quality Services. I will talk to you about the strategy for that when you want to lift and shift that to the cloud also. So the first recommendation to do is like find the full compatibility solution where you can lift and shift your solution to the cloud without change. For the database engine, the recommended solution is Managed Instance. Managed Instance is essentially a variant of Azure SQL Database that's provide almost 100% backward compatible for SQL with SQL Server on-prem. And SSIS in ADF is also providing close to 100% backward compatibility for SSIS on-prem. Once you do the full compatibility lift and shift, you can do either partial lift and shift or complete replacement. The SSAS analysis services, we don't have a full compatibility lift and shift. We only have partial lift and shift. Essentially, if you have tabular model, you can use the Azure analysis service in the cloud. But if you have multi-dimensional model, you still need to use the SSAS on-prem or on a VM. With the SSRS, it's actually, we don't even have a cloud solution. So for that one, you need to really replace it with a complete SaaS solution, which is Power BI, okay? Now, most presentation on SQL migration stop at this slide. What I want to show you is like the role of SSIS in ADF as a glue that actually connect all these disparate resources in the cloud and on-prem together. You can see with SSIS, you can connect to your tabular model in AAS, because we have AAS components, right? And if you leave your multidimensional model on-prem, we also have a SSAS component to refresh that model on-prem. And with Power BI or Excel, you can create a Power Query script. And this script can actually be operationalized on SSIS in ADF. You can actually just simply cut and paste your script that transforms data using Power BI and run it like regularly on SSIS in ADF, right? And you can host your catalog, SSISDB, in Azure SQL Managed Instance. And while you're running your ETL in the cloud, you can still reach down and extract data from SQL Server on-prem if you have not retired it, for example. Once you run SSIS in the cloud, like I mentioned before, it becomes it's ready to be modernized, essentially. You can actually combine with all these different connectors that comes built in with the ADF. ADF keep adding more and more connectors. Last time I count is 80 plus, I think about maybe 89 now. So you can see there's like even AWS connectors, Google Analytics connectors, Apache, Impala, etc. So you can actually combine your SSIS package execution with ADF copy activity in a pipeline, just like a Lego approach, like a mix and match, right? And if you don't find any of the built-in connectors meet your purpose, you can actually extend it. Like I mentioned before, we have an interface where you can actually bring your own custom connectors or custom tasks, and we have partners that built their own license component to run on SSIS in ADF. For example, I'm pretty sure you probably heard these names before, like Pragmatic Works, SentryOne, Kingsway, Soft, Cozy Rock, etc. Right? The one that I want to highlight is like the little one in the bottom is there's a partner in Germany, it's called OH22. They actually built a data quality component running in SSIS and EDF. And it's actually ready to migrate your data quality knowledge base from DQS on-prem to the data quality workload running on SSIS and EDF. So that's why for all those bundled services, we have already a solution for you to run it in the cloud. Okay? So let's go on the evolution of SSIS, how we modernize SSIS from on-prem to the cloud. What I wanted to highlight is 1 year that is really a big bang year for us is 2017. So it's 2 years ago. I think we announced SSIS in ADF about 2 years ago at Ignite, right? And at that year, we announced 3 major features. The first one is essentially you can run SSIS on Linux now. And even I think we launched that with Red Hat and Ubuntu. You can run SSIS on Linux, and I think with the SQL 2019 in the future, you can run it with the Red Hat 8.4 or something like that, right? So the Linux extension, we keep make sure that we support the latest version, right? The second feature, the big feature that we launched in 2017 is the scale-out feature. And this is actually formed the foundation for SSIS in ADF. The scale-out feature is essentially a way for you to manage multiple machines in a master worker topology, and you can parallelize your package execution across these multi-machines, right? But the point with the scale-out feature is you have to manage all the machine. So that's why the third big feature that we launched in 2017 is managing this cluster of a master worker engine in the cloud in the form of a platform as a service. And we integrate SSIS in ADF with a native compute engine. So the way we do it is like, if you remember, when running SSIS on SQL Server, your compute and storage is in the same instance. So SSISDB on SQL Server and the SQL Server machine itself running the ETL workloads, right? When we run in the cloud, we separate compute from storage. So the storage where you store your packages can be inside SQL DB, standard SQL DB, or the managed instance. So you can have SSISDB hosted by those instances, right? But the compute is essentially moved to Azure Data Factory, so storage and compute, and you can scale them independently from each other. So you can scale up and down the SSISDB or scale up and down the compute in ADF, right? The compute in ADF that has the capability to run SSIS is called Azure SSIS Integration Runtime, or for short, SSIS IR. I will mention IR most of the time, okay? And the one thing that we also introduced about a few months ago, actually coinciding with the end of support of SSIS 2008 or SQL 2008, right? With SQL 2008, there's no concept of SSISDB or a catalog, because most of the time you run your package from a file system. So we actually introduced this interface. Now in SSIS and ADF, you can also run packages stored in Azure Files or a file share. And that's actually helped a lot of the migration process, because now you don't have to switch from a package deployment model, which is storing packages in file system, into the project deployment model where you store the packages in SSISDB. You can, in fact, just move the package from file system on-prem to Azure Files in the cloud. Just copy, manual copy, or use DTUtil, and then suddenly your SSIS and ADF can run your packages in the cloud without using SSISDB. So that's one feature that we released to unblock the migration. And next, let me see what it is. Also, we enable all these traditional tools. One of the design decisions we make is making sure that you don't have to actually upgrade your skill set too much. Because you are familiar with SSDT, SSMS, SQL Server Management Studio, SQL Server Data Tools, right? With the command line utility like DTUtil and DTExec. So instead of learning all the new tool in ADF, you can still use all those traditional tools. What we do is we Azure enable them. So for example, in demo later, I'll show you how to actually test your package in the cloud using the same interface in SSDT. In the menu in SSDT, not only there's execute package, there's a new menu, it's called execute package in Azure. So you can do that. So in SSMS also, you can actually, in SSMS, if you want to schedule a package, you can either use a SQL agent, but there's also a menu in SSMS to actually schedule execution of the package in ADF. So you can actually auto-create ADF pipeline and activities running the package in ADF using the SSMS interface. The one thing that I really cool that we just released, I think about a few weeks ago, is the Azure-enabled DTExec. DTExec is usually used by a third-party scheduler or orchestrator, like if I remember correctly, like Active Batch or Control M. Most customers use this third-party orchestrator to invoke DTExec that will actually run the packages on-prem, right? So when they lift and shift their package in the cloud, they told us they don't want to switch their orchestrator or scheduler because they have built their whole operation teams based on this notification and monitoring on this third-party system, right? So what we do is like instead of like asking them to switch orchestrator, we actually Azure enable DTExec. So instead of invoking DTExec, now the third-party orchestrator can invoke Azure DTExec. Same interface, but what happened under the hood, we actually call in an interface REST API to execute the package in the cloud inside ADF. I will show you the demo of that also later. Okay, and one thing that we also add, we provide the custom setup interface with SSIS and ADF where you can install custom component, etc., right? And one thing that's really important to remember is like, because you're already running SSIS on-prem, you already paid for the license. You already paid for SQL Server license, right? So when you lift and shift in the cloud, you can actually, there's an option to provision SSIS IR in ADF, which is called Azure Hybrid Benefit, or bring your own license. With this, we don't have to charge you anymore the SQL Server IP or SQL Server license. We just charge you essentially the bare bone raw machine, the cluster, and the management service. So that way, your running costs of executing SSIS in the cloud is cost effective. So you don't actually have to pay for extra license. I'll show you the difference between running with a new license and running with bring your own license. Okay? All right. So next, once you have your SSIS packages running in the integration runtime in ADF, you might still have some data sources on-prem, like a file system or SQL Server, etc. We have two methods to reach down from the SSIS in the cloud to extract those data from on-prem. The first one is VNet injection. What you do is like when you provision your SSIS IR, you're joining the SSIS IR compute into your own VNet connected to your on-prem network. That way, all your on-prem network will adopt the private IP range of the VNet, such that your package can actually reach down and have a line of sight to those data stores, right? The other way to do it is also using a gateway or what we call a self-hosted integration runtime. With this one, you essentially install a runtime on a local machine behind your corporate firewall. And then when you run your package, under the hood, we actually deconstruct your data flow tasks. So instead of moving from source to the destination, we divide it into two legs. The first leg will be moving the data from source on-prem using the self-hosted IR to a staging area in Azure Blob Container. And then the second stage is basically running with SSIS IR in the cloud, moving the data from the staging into the destination. I'll show you the pros and cons between those two methods, okay? And like I mentioned before, once you run SSIS in Azure Data Factory, you have all these new cloud-only features. For example, if you don't like to keep your credential inside your package, there's an integration with Azure Key Vault. So that way, when you run your package, at runtime, SSIS Integration Runtime in the cloud will actually fetch your access credential to your data store from Azure Key Vault. Or if you don't want to use credential at all, you can use AAD authentication or Azure Active Directory authentication using ADF managed identity. What you do is like you have to provide permission for ADF to access your data stores. And then when we execute the package, there's no credential at all. We just use the ADF managed identity to access those data stores. And that's only available in the cloud. Okay? And running SSIS in ADF is a complementary. Like I mentioned before, SSIS can be extended with all this new ADF connectivity. And vice versa, ADF user right now actually start using SSIS to fill the gaps in some of the data sources. For example, we don't have ADF native Excel connectors right now. So some of ADF customers actually use an Excel source and build a small SSIS package inside their ADF pipeline to connect to Excel source. So it's actually a complementary win-win combination. Okay? All right, so now let's talk about the methods to access on-premise data, right? Like I mentioned before, there are two methods. The right-hand side is when you join your SSIS IR into a VNet connected to your on-prem network, and that way, all your on-prem data stores will adopt the private IP range such that your IR can actually reach them, right? The second one is, like I mentioned before, you install on a gateway or a self-hosted integration runtime on your on-premise location, and that will actually break down your package. Everything is done automatically. From your point of view, your package is a simple data flow. All you need to do is enable one property called connect by proxy. When we see that connect by proxy attribute or property, we just automatically deconstruct your data flow into two stages. Okay? So let's drill down to the VNet solution first. This one, there's a bit complex diagram there. What you do here is actually injecting your SSIS IR, the SSIS and ADF compute engine, inside your own VNet connected to your on-prem network. Once you do that, then you can reach down to your on-prem data stores using basically all the connectivity available with SSIS, right? The only issue with here is like because usually you want to secure your VNet tightly, right? We still have to, the backend service of ADF still need to manage the SSIS IR inside your VNet. So there are some rules that you have to follow. For example, opening some ports such that our backend service can manage the compute engine inside your VNet. There are outbound traffics, like on port 1433 to connect to SQL DB, 433, you have to open it to connect to Azure Storage. And then there's a special one which is actually an inbound traffic. That inbound traffic is needed for Azure Batch. Azure Batch is actually the underlying infrastructure where we build SSIS engine in ADF. And that inbound traffic is needed for Azure Batch to connect to the Azure Batch agent in each node of your SSIS IR inside your VNet. Some corporations actually don't like that idea of allowing inbound traffic. So we have to explain that this is actually a secure inbound traffic. It's purely between Azure Batch backend and Azure Batch agent. It's completely encrypted, and it's purely only for a control plane. It has nothing to do with data plane, right? So essentially, as I mentioned before, the positive of VNet injection is it's a managed infrastructure. There's no gateway you need to install. Everything's managed by us, right? You have all the connectivity available, and there's no staging because it's directly from on-prem source to the cloud destination, or vice versa, right? The cons is, like I mentioned before, it's a bit complex. For example, we have customer who wants to audit all traffic. So in this case, they will actually do a forced tunneling of all traffic from their VNet into like a network appliance, right? So that way they can audit all the inbound and outbound traffics. Outbound traffic can be tunneled into this network appliance, but inbound traffic, you cannot do that. So if you do that, it will break. So what we offer them that you actually, when they want to do this type of forced tunneling solution, they have to open a UDR, user-defined route, such that the inbound traffic between Azure Batch and the Azure Batch agent inside the cluster has to go through a next hop internet, for example. So that's why it's a bit complicated. On the self-hosted IR, it's a bit simple. There's no more inbound traffic requirement. There's only outbound traffic, right? There's only 433 and let me see, 1433, right? And you just install your gateway behind your corporate firewall. The pros of this self-hosted IR solution is very simple to use. There's no change in the package. You just basically enable a property called connect by proxy on the connection manager, right? And you can also reuse the link service for the stagings. For example, in ADF, if you already have Azure storage used anyway, you create an Azure storage link service, and you can use that for the self-hosted IR. The cons of this is essentially you have to manage your own machine and manage infrastructure. It has limited connectivity. For now, we support only OLDB and flat file source and connection manager. And just about this week, we released an ODBC source and ODBC connection manager. And in the near future, we'll probably add more connectivity, for example, Excel source, SQL task, etc. But it's a slow process because we are basically adding the self-hosted IR support connectivity by connectivity. Okay? And obviously, there's a little latency involved. Because now the data flow will go through staging first, right? So you have to choose between, there's a trade-off between complexity and managed infrastructure, etc. So you can choose which one the solution better for you to access on-prem data, okay? So finally, we'll go through the complete SSIS migration playbook. First, I will go through the SSIS migration process. You can see as a DBA, for example, you have like 1,000 of packages, 1,000 of projects. You want to make sure that your project and packages actually can run in the cloud. We have a tool actually that you can use for that. It's called DMA, Data Migration Assistant. You can download that tool and run on your locally on your machine, and then you just point it to your for your file share or your SSISDB or even your MSDB or SSIS package store where you store your packages, and you can see the assessment result. You can have a report which packages need to be changed, which packages need to be adjusted so it can run in the cloud, right? Once you have the full report, usually the DBA will pass it to the BI developer, and the BI developer use that report to run SSDT. And in SSDT, they will see like the BI developer will find out like which package needs to be modified, which package needs to be changed. Oh, but before I start, I apologize for the avatars being chosen. It looks like our designer just picked a follically challenged DBA, and then like the BI developer is like a punk rock guy. But like, never mind. There's no hidden connotation in that anyway. So once the BI developer change all the packages and ready for migration, then you can do a batch migration. There are two tools to do that. Like you can use a cloud service tool, which is called Database Migration Service, or DMS. You can do batch migration from SSDB on-prem to SSISDB in the cloud. We are actually adding more and more feature on DMS. DMS is actually a bit behind than DMA. DMA already support all kind of package store, but DMS only support SSISDB right now. In the future, DMS will support also migration from file system or MSDB or package store, right? Or you can use a DTutil. DTutil can do like a batch migration of all files from file system to Azure files, okay? Now we'll cover the SSIS migration playbook. So the migration playbook is essentially a 4x5 matrix. Let me just show you all the matrix. Right? You can see it's a 4x5. 4 is the row where you actually store your package. You can have packages stored in SSISDB, in an old SQL Server MSDB, or on file system, or on SSIS package store. On the column, right, it's based on the destination of your migration. You can migrate your packages into SQL managed instance, and then you migrate your SSIS job from SQL Server agent to managed instance agent, because SQL Server managed instance has a managed instance agent in the cloud. If your destination of migration is actually Azure SQL DB, then for that, you migrate your packages from SQL Server to Azure SQL DB, but your jobs from SQL Server agent has to be migrated to ADF as a pipeline and trigger and schedule, etc. And you can see in each of the cell of the matrix, we have this green text. The green text is essentially the action that we recommend. Either use the first class tool that's already ready. For example, if you have packages stored in SSISDB, you can already use DMS to migrate from from SQL Server to MI. But if you have a package, your destination is SQL DB, DMS doesn't support that yet, but you can actually just redeploy the packages or using some script, right? So basically, in some of the legacy package storage, you might have to actually convert from like MSDB or package store to the file system first. Basically, just extract those packages from MSDB to file system, and then use DTUtil to deploy, and basically the jobs to use some script to move SQL Server agent jobs into MI or to ADF. Okay, and that's essentially the complete SSIS migration playbook. It's always changing because we keep adding features. For example, instead of DMS, we're also adding the batch migration feature on SSMS. So in the future, you can actually use SSMS to batch migrate packages if you need so. Okay. All right. So I think I cover all the content. So we have 15. So we have 30 minutes for demo. Let me switch to demo. Okay. All right, let me switch the screen. Okay, we start with my Azure dashboard, right? All those square, those tiles are all my Azure resources. I have already created Azure Data Factory, and and I also already pin my Azure Data Factory to the dashboard. I'm gonna open one. This Sawinark is my alias, so it's Sawinark ADF v2 is my Azure Data Factory. When you click on it, you go to the home page of the Azure Data Factory, and you can see this author and monitor tile. When you click on it, you essentially open the Azure Data Factory UI or app, where you can actually provision the SSIS IR inside ADF, okay? And you click on that, essentially what you're going to see is this, right? So you end up in the home page of the ADF UI, and you can select this fifth item, which is actually configure SSIS integration. This is where you provision the SSIS IR inside ADF. When you click on it, you can see the provisioning blade. Yeah. So there are 3 blades here. There will be compute blade, SQL blade, and advanced blade settings, right? On the SQL settings, you can give the name, in the compute settings, you can give the name for the integration runtime, in this case, integration runtime 1, right? You can put your description, and then you can select the location. We have, I believe, up to 26 regions already available all over the world, and we keep adding more and more regions every 2 months, okay? For this demo, I select West Europe, for example, right? And then the node size, we have a lot of different sizes for the nodes, all the way from 1 core to like, I think, 64 core here. And you have 2 versions, the D series and E series. D is a general purpose VM, while E series is more memory optimal VM. This is where you use, for example, to run a package that you need to use a lot of memory, for example, sorting packages, etc. Right? And you can see when I select those packages, before I do that, you can select also the number of nodes in the cluster. Yeah, in this case, like by default, you select 2, so you have a high availability. If one node is not available, the other one ready to pick up any package, right? You can provision all the way up to 10 here, or 1, the smallest one. And then you have a license. You have standard license and enterprise license. Just like what you have on-prem, you have a SSIS standard and SSIS enterprise, right? Enterprise edition essentially allow you to use the premium or advanced component like a CDC, change data capture, Oracle, Teradata connectors, SAP connectors, I think fuzzy lookup, fuzzy grouping components. Those are come with Enterprise Edition. And obviously, Enterprise Edition is a bit more expensive. You can see here, if I change this, we show you the indication of the cost per hour. If I switch to Enterprise, it's more expensive, like $4 per hour. This is all full license, okay? If it's standard, it's like 1. And if one node is and then if I go to 10 nodes, it's going to get $19 10 times, right? And you can change the, if one core is probably cheaper, it should be cheaper. Let's see, where's the one core? Here. It's like only 50 cents per hour, one core. 64 core, it costs about $18 per hour. But what I want to highlight is like the way to save money. There's an option here to save money, which is the Azure Hybrid Benefit. When you click on this, you don't have to pay the license anymore. You essentially pay, like I mentioned before, you're just paying for the VM costs and the managed service costs, right? So in here, you can see, if I change my, my enterprise, my edition from standard to enterprise, the price, $11.98, for example, right, doesn't change. Because basically our backend don't care about the license type, because we will provision the correct license, but you basically tell us you already pay for those license anyway on SQL Server, so you just bring it up to the cloud, okay? So for this demo, I'm gonna use the cheapest one, D3V8. Let me see, where is that? 8 core, and I use one node, right? And then click next. Next, essentially, the SQL setting where you decide where you want to host your packages. You can use SSISDB hosted by Azure SQL Database or managed instance. In here, you have to provide your Azure subscription, and then after you provide your subscription, you select the region. The region usually have to be the same with the IR, because remember there's a separation for compute and storage. If your compute is actually in West Europe, you should actually have SSIS be hosted in West Europe also, because when you execute a package in ADF, we always want to write logs back to SSISDB, right? So if SSISDB actually in East US, then those log writing will actually go cross-continent. I mean, it will work, but there's some latency involved. So the recommended practice is always SSISDB and SSIS IR is hosted all in the same region, okay? And then you select your database server endpoint. Here you can select either managed instance, Azure SQL Database. You can select private endpoint or a public endpoint. Here, if you select a private endpoint, the interface will actually tell you that you need to inject into a VNet, because a private endpoint is inside the VNet, so that means your IR, in order to connect to SSISDB, have to be injected into the same VNet, okay? And you can also select either using SQL auth, because what happened is like you have to give us the server admin credential so we can create SSISDB on your behalf. And when we do that, essentially, once we create it and we drop the server admin credential, we just only use it once to create the internal account to manage SSISDB for you. But if you don't want to use SQL auth, you can select AAD auth. In this case, you don't have to provide a server admin credential, but you have to give a role, a DB owner role, to ADF, Azure Data Factory. So Azure Data Factory can actually access your SQL DB or managed instance to create a SSISDB on your behalf, okay? The one thing that I want to highlight for you is the fact that like before I think before the 2008 end of support, you always have to bring your own SQL DB server for us to create SSISDB for you. But now, because we support the package management package deployment model, you can host your package in Azure files. So you don't need SQL managed instance or SQL DB anymore. You can just click here, optional. And that's it. So essentially, that means essentially saying like, please provision SSIS IR in the cloud, and I will use Azure Files or a file system where I store my package. So you don't have to bring database anymore. Okay. So next is the advanced settings. Remember that the SSIS IR is a cluster of VM. You can have multiple nodes inside the VM, 1 to 10. So if you have 10 packages, you can run 10 packages in parallel, and each node will pick one package. What if you want to actually go into deeper parallelization? So instead of running packages per node, you want to actually run a package per core, right? Because I provisioned my IR in this example with 8 cores, right? If you have very, very small package that you want to run, you don't really need all the 8 cores. So you can actually adjust the maximum parallel execution per node. So if I put 8 here, that means I can actually run one package, one core. So because I have, let's say I have like a two machines with 8 core, right? That means I can run 16 package, because each core can run one package. And actually, the limitation is actually 2 times core. So actually, in here, I can set up all the way to 16. See? With 16 parallel execution per node, it means Each core can take 2 packages. So it really depends. If you know your package is really big that needs all the core, like I mentioned before, if you have like a heavy compute, like sorting package, etc., you want to take advantage of all the cores to a package. But if you have a simple one, you can have half a core to run a package. Okay? You can set all this up when you provision your IR. And you can configure your IR on the fly depending on the package, the characteristic of your package. You can scale up, scale down, scale in, scale out. So this is the advantage of running SSIS in the cloud, right? You cannot do that on-prem. You cannot like buy and sell SQL Server on-prem. But in the cloud, you can decide the number of cores, the number of nodes dynamically. Okay? Let's go back to 8. Now, the next advanced settings is essentially the custom setup interface. Here, if you check this checkbox, you have this field which is called the custom setup SaaS URI. In here, the interface is essentially saying if you bring a SaaS URI is a shared access signature uniform resource identifier. It's essentially a URL of your blob container. If you bring a URL of your blob container where you store your custom setup files, for example, if you have a Kingsway Soft component that you want to run with your package, you can essentially put the Kingsway Soft MSI in a blob container with all the associated files, and you have entry script called main.cmd. The main.cmd essentially will say execute the MSI exec the Kingsway Soft MSI, for example. And then that URI will be seen by our IR when we provision. Basically, each node of the integration runtime will go to your container, download all the main.cmd custom setup script, and all the MSI and install it on all the components. So essentially, it's very flexible. You can do anything in there. You can, inside the main.cmd, not only installing custom or open source, you can actually start up some Windows services. For example, some customer are actually using it to start the MSDT exec. No, sorry, what is it? MSDTC, Microsoft Distributed Transaction Coordinator. That Windows service by default is not always started, right? But you can use the custom setup to actually start that service. So it's very, very flexible. But obviously, the throwback there is you have to actually create a script, right? So we're going to add more and more non-script custom setup, what we call Express custom setup. So this new feature here, Express custom setup, you can click New. And here, we have now 2 custom setup that doesn't require a script. Essentially, you can run command key, for example. Do you know what command key is? CMD key, Windows command. The CMD key is used to persist credential. For example, if you want to, for your IR to connect to Azure files or to like a SQL Server or something, you can actually run a command key to set up the target, the domain, and username and password set. To do that, usually you do it through the custom setup script. In here, you can actually do it by entering the parameter. You can see you can put the target, the user, and the password, essentially. And you can persist different credential for different file shares. And you don't need to bring a custom setup script anymore for that. So that's one way for us to optimize your custom setup. Another one is to create a Windows environment variable. For example, you want to create a temp variable. You can actually create a temp variable through this interface. You don't have to actually put a script anymore. Okay? So that is the custom setup. Another option here is, like I mentioned before, if you want to access your on-prem data, you can actually inject your IR into a VNet connected to your on-prem network, right? Here you can select what the VNet is and the subnet, and then we will actually inject the IR into that VNet. You usually use VNet also to connect to data stores that has a firewall. For example, if your Azure storage is set up with a VNet service endpoint, that means only a certain resources inside the subnet or VNet can reach that data storage, Azure storage or SQL DB. Then you can inject the IR into the same VNet and subnet. So you can use it for on-prem data access or accessing isolated sources or destination that's configured with VNet service endpoint. Okay. That's one option. Another option is like the setting up the self-hosted IR, where you want to do access to on-prem data without using a VNet. Here you actually basically link a self-hosted IR with the SSIS IR in the cloud, and then you can install the integration runtime on your local machine connected to your on-prem data stores. You can select, for example, the name of the self-hosted IR. For example, I already have 2 self-hosted IR installed, one in my laptop here and another one in my desktop in China. I can select that if I want, right? And then you provide the link service. The link service is essentially it's a pointer to where you want to do your staging. So here is like we will do the staging in Azure storage. So you provide a link service to your Azure Blob storage, for example. Okay. And that's it. For this example, I just leave all the options off and just continue. And I'll show you all the summary page of all the settings that you do. And when you create, that's it. And then your IR will be created in the cloud. And I can show you the monitoring page of the IR. For example, here, you see the new one here, Integration Runtime 1. It's actually just starting because I just started to provision it here live, right? But last night, I already provisioned some of the IR in advance. Oh, actually, do we run out of time? Sorry? Oh, sorry. It's so quick. OK, so like you can actually monitor it very quick. You can monitor your IR when you're running it. Let me just click in here, all right? And then you can run your package. That's why I'm running around time. By the way, if you want to ask more questions later, you can just find me in the database migration booth or my Expert Connect, right? I'll just show you quickly the menu that I mentioned before. Like in here in the SSDT, you can actually look at the here, execute. You can see execute package in Azure. You can actually run it in there, right? And yeah, and then like in ADF, you can see, let me see, the pipeline here. One thing that I want to show you really quick with here, right? This is a pipeline and activity that run a package. In the location, you can see you have SSISDB, file system, in the package or file system project or embedded. Embedded is essentially you can drag and drop package, for example, from your folder into here. Here, let me just show you quickly. You can see here, I have a package here. I can drag and drop. You see? So you can actually drag and drop package from your Windows Explorer to, that's a brand new feature. It's about like a week ago released. So because we are running out of time, I'm just going to show you quickly my address, email address, so you can take a picture and ask me a question later on, okay? Let me just show you. Where is my? There you go. Okay, so that's my email address. And there's also a Yammer discussion group for under NDA where you can actually talk about new features with us. And then there's a SSIS team blog that you can visit. And if you have any questions, come by here or later find me in the database migration booth from 4 to 6 and the Expert Connect session. Okay, thank you. Thanks for coming.